So I welcome all of you to my next one of the session related to quantum numbers from Essentials of Chemistry. So quantum numbers, we know there are basically four quantum numbers and very essential to describe uniqueness of each and every electron to determine or to specify or to name which electron exactly it is. We need to explain all four quantum numbers. If one is missing, then it is difficult to differentiate it from another electron. Okay, so uh, I'm Dr. Sushan Lal Babu, Assistant Professor, Aerospace Division, Indian Institute of Technology and Science. And today we are going to discuss about the significance of quantum numbers. So most of them already have covered this particular session or topic in your 10th, 12th level. And here we are remembering or understanding the significance once again. So we will discuss what we learned earlier. Also, we try to add something more. If you forget, means we can refresh it. Okay. So there are basically four types of quantum numbers. What are the four types of quantum numbers? First one, it will be what principal quantum number. Second will be azimuthal quantum number. Next, magnetic quantum number. The last one is spin quantum number. Okay, each and every quantum numbers are having its own significance, its own purpose. Okay, what it's defined or what it explains. So what uh, electron, what details of electron each and every quantum number will provide. It, we have to differentiate it very clearly. Okay, we have to know the difference very clearly. So we will go to the next slide. So before going to the explanation, so what are quantum numbers? It describes electrons' trajectory and movement within an atom. An atom consists of a nucleus at the center and neutrons, protons within the nucleus. Positively charged protons will be there inside, and the neutrally charged neutron also will be there inside the nucleus. And around the nucleus, there will be a sub what shells or energy levels where can be uh, electrons are occupied. So that electron's trajectory and movement within an atom around the nucleus. Uh, Quantum numbers explains or describe that trajectory with the help of Schrödinger's equation. That quantum numbers also explain the position and energy of an electron in an atom. Okay, so these are these some objective, or the quantum numbers will give what we need to identify which electron is there in the which shell or subshell or which orientation it is or which spin it is having. So that all details we will these quantum numbers will explain. So these are the four basic quantum numbers. That is principal quantum number and azimuthal quantum number, then magnetic quantum number, then spin quantum number. Okay. So each and every quantum numbers are having specific definitions or purpose. So what the principal quantum number will explain. It describes the electron levels of an atom, at which energy level it is occupied or at which shell it is occupied. This principal quantum number denoted by N. Letters are having very importance. Okay, don't mix it up or confuse it. Principal quantum number is represented by N. It tells the level, which energy level the electron is occupied. Azimuthal quantum number is L, represented by L, which gives the shape of the electron cloud. What is electron cloud? The probability, maximum probability of finding an electron. The region where we can find an electron. That is put forward by the Schrodinger. With the help of Schrodinger wave equation, he found out at each level, energy levels, where we can find an electron, whatever the maximum probability of finding an electron at different energy levels. Okay, so he has proposed several shapes where we can find the electrons in consecutive energy levels. So that shape of the cloud, the azimuthal quantum number will explain. Then magnetic quantum number, okay, is represented by ML. It explains the orientation of the uh, electron cloud, and spin quantum number tells the spin electrons and and it tells us the spin at what direction or what orientation the electron is spinning, and it's clockwise or anti-clockwise. Okay, so next, the quantum number, we can see that we have already explained about size, shape, orientation. Size, it's energy level. When the energy level increases, size of the orbitals also increases. You can see n, this one represents the n, this represents n equal to 2. But so next, energy level means the size of that s orbital increased. So that n represents n increases, size increases, energy also increases. So size, next quantum number will give shape, azimuthal quantum number will give orientation. So for example, px, py, pz. So I can see here it is oriented along the x-axis, here it is along the y-axis, here it is along the z-axis. That is different orientation. One single uh, subshell of P is having three different orientations. So azimuthal quantum number only can explain at what orientation that P subshell is having or which subshell the electron is occupied. Okay. Last one is spin quantum number. So first we will discuss about the principal quantum number. Principal quantum number, we can see that n is 1, 2, 3, and so first energy level is 1, second energy level 2. Likewise, it will go on. Okay, so energy level means around the nucleus where the electrons will orbit or will occupy over on the orbits or orbitals. So principal quantum number. Next, you can see at n equal to 1, E1 will be the energy, and n equal to 2, we can represent the energy possessed by the electron, or electrons can be yours as E2. As earlier we discussed, an energy possessed by the larger orbit will be higher compared to the lower orbits or smaller orbits. Okay, so this is the electron cloud. So this is an what a real time scenario. So it's a cloud of probability. Based on the probability, we will say where we can find the orbitals here, 1s, 2s. Okay, electron cloud. And also we can using, okay, n equal to 1 and 2, 1, 2, 3, 4. Also we can say in as names KLMN accordingly for each and every energy levels. Next comes the number of orbitals. If we know the value of n, then how we can identify how many number of orbitals and how many number of electrons are there in each and every subshell, so that we can find. So number of orbitals can be obtained by this formula. N is equal to, sorry, a number of orbitals is equal to n square. Orbitals mean subshells. Hmm? So n is equal to n square, and each subshell total number of electrons can occupy maximum is 2. Every subshell and its maximum of 2, not more than that. Only two elements, two atoms, sorry, two electrons a subshell can take. So if we know number of orbitals or subshells, then how many total number of electrons will be there? It's easy, because multiplied by 2. In every subshell, 2 electrons can be occupied. So number of subshells is n square, means number of electrons will be 2n square. Okay, n equal to 1. So one subshell will be there, yes, 1 is. Next is n is equal to 2. So what are the subshells? 2 means 1s will be there, then px, py, pz will be there. Okay. So just this representation, and that we can define using why this three are there. This is S, this is S and P, this is S, this is P, and this is D. So you can see n equal to 1 means how many number of subshells will be there? 1 square 1. That is this one. And n equal to 2 means how many number of orbitals will be there? 2 square 4. That is 1, 2, 3, 4. So like that, n equal to 3, how many will be there? 3 square 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what the so number of electrons. Next, one n is equal to 1. N square means 1 square number of subshells into 2, 2. N is equal to 2. That 2 into n square, that is 2 into 4, 8. Okay, you will get. N equal to 3 means 3 into 3 square is 9, 9 into 2, 18. The number of electrons will be there. And n equal to 4. 4 square means 16 into 2. 32 number of electrons will be there in the nth shell. Okay, that is what they explain. And the energy order of energy will increase from k to n. Okay. So 1 to 4, the energy will increases. Next is azimuthal quantum number. Azimuthal quantum number is represented by L. And just you need to remember, azimuthal quantum number for S always will be 0. L equal to 0 represents S orbital. L is equal to 1 represents always p orbital. L is equal to 2 represents always d orbit. So, so we can represent it as azimuthal quantum number will explain, give details of what shape. So L is equal to 0 means yes, it is having spherical shape. L is equal to 1 means P, it is having double shape. Okay. So it explains which orbital is it is S or P or D or F. It won't explain any orientation of any orbital. It will explain only shape, size. Second, first one is size. Principal quantum number explains size. Second, azimuthal quantum number explains shape. What shape that orbital is having. Okay. So you can see n equal to 1 means only one orbital s. N equal to 2 means there will be s and p. And n equal to 3 means there will be s, p, d. And n equal to 4 means there will be s, p, d, f. So how we can represent? How we can formulate an how many, what is the formula of L value depending on n value? So you can see that n equal to 1, 1. So that is L is equal to 0 here. Here L is equal to 0, L is equal to 1. Here L is equal to 0, L equal to 1, L equal to 2. At the last, the fourth shell, S means L is equal to 0, P means L is equal to 1, and D means L is equal to 2, and F means L is equal to